Good morning, sir.
Yes, very good morning. Okay, all of you scan this QR code for the attendance. Wait for a minute or 2 minutes, then we will start. Okay, so let's start the session. Yes, the screen is visible. Yes, if the screen is visible to all of you.
Yes, sir.
Okay, so today we are going to start a new module. Okay, it's the last module. Which covered your concept of virtual memory and CPU utilization or CPU scheduling. Okay? Sorry, we can say hard disk scheduling. ठीक है, दो चैप्टर बचे हैं आपके, एक आपका वर्चुअल मेमोरी, कॉन्सेप्ट ऑफ वर्चुअल मेमोरी एंड how we can manage the hard disk scheduling. So we will first cover up this virtual memory concept. Okay, then we will see about how we can schedule the process in a hard disk. So in this chapter, basically the background that we are going to cover is we will cover the basic concept of virtual memory. That is why we require a virtual memory. ठीक है, virtual memory हम लोग को क्यों चाहिए and what is the benefit of virtual memory, and how we can achieve this concept. Okay, how we can achieve this concept of virtual memory. Then we will see something about the demand paging. The demand paging is the process. Okay, the demand paging is a process which is used to achieve your वर्चुअल मेमोरी कॉन्सेप्ट. वर्चुअल मेमोरी कॉन्सेप्ट को इम्प्लीमेंट करने के लिए हम लोग क्या यूज करेंगे? डिमांड पेजिंग. देयर आर टू मेथड एक्चुअली. वन इज योर डिमांड पेजिंग एंड सेकंड वन इज योर demand segmentation. These are the two methods which is basically used for achieving the concept for virtual memory. Then we can see how the virtual memory concept can be used for the process creation. So it is one of the applications. Okay, the virtual memory implementation, or we can say the virtual memory concept, is one of the applications used in your process creation. Then we will discuss some of the algorithm that is related to the page replacement. So there is basically three algorithms are there, three different algorithms are there. So which is used for the page replacement. Page replacement means, so whenever the page which is needed by the CPU are not present in our main memory. जब कभी भी जो पेज CPU रिक्वेस्ट करता है वो अगर मेन मेमोरी में नहीं होगा, okay, then there will be a page fault. If there is a page fault, I have to bring back. That page should be bring back from secondary memory to the main memory. And this is called, we will use some of the algorithm for page replacement. So we'll discuss about this in detail. Then we will discuss something about caching. Again, the caching is very important concept relevant to your operating system. Okay, and it is deal with your page fault. So as the page fault increases, what will be the system performance? So we will study the system performance with relevant to the page fault using the caching. Then there is some of the operating system examples are there for virtual memory concept. Basically, a solar memory system or solar operating systems are used. So we will discuss that. So this is a the total topic that we are going to cover in case of virtual memory. Fine, is it clear to all of you what we are going to discuss in this chapter? So the very important part in this chapter is your page replacement algorithm. This chapter में सबसे important part है page replacement algorithm, and second most important part is your caching. How we will implement caching. Fine, these two topics is very important regarding this virtual memory concept. So let us begin with this. Yeah. So anyone can define what you understand by the virtual memory here. क्या समझ में आ रहा है virtual memory से? Yes, anyone can define what you understand by the virtual memory. Yes.
Sir, the part of memory which operating system stores for the context switching.
Okay. Any other simple definition for that? In general, logical, in general, आपको बात करना बोला virtual memory. So is it a original memory that we are having, or it is something logical memory? क्या होता है virtual memory? आप बोल रहे virtual memory, क्या originally वो सिस्टम में होता है या फिर ऐसे लॉजिकल है, कुछ लॉजिकल टाइप मेमोरी? So if you see the architecture, हम लोग architecture देखते हैं. Now there is a one type of memory we already studied, which is your main memory. है कि नहीं? Your main memory, and there is one more memory called your secondary memory. है कि नहीं? Yes, these two are the actual memory that is present in my operating system or in my system. हम system में बात करेंगे, there are two memories only available. Okay, apart from that, there are other memories like cache memory and register memories. So we will not talk about that for the time being. So time being we will बोलेंगे कि अगर जो actual memory आपके system में दो ही है, आपका main memory है और आपका secondary memory है. But apart from that, So what we are having, so we will assume that there is one more memory in between these two. In between these two, there is another memory, जिसको हम लोग बोलेंगे virtual memory. Okay, virtual memory. Now this is a logical memory. This is इसका really exist नहीं करता. There is no hardware like a virtual memory in my system. Is it clear? आपका हार्डवेयर कोई ऐसा नहीं है वर्चुअल मेमोरी बोल के. Now this is a logical memory. That means we are assuming that now we have in the assumption that there is a virtual memory in between the main memory and the secondary memory. Now, what is the benefit of using this type of virtual memory? What is the benefit of that one? What is the benefit of that one? Now, the accessing speed. So, whenever you need, suppose you have to transfer the data from secondary memory to main memory, the data transformation is very large. For example, now assume an example here. Now, आपका एक process है. Suppose I am assuming P1. Now, suppose P1 is consist of 1,000 pages. Now suppose the pages are fragmented here. Now page 1 आपका यहाँ पर है, page 2 यहाँ पर है. Now page 3 will be somewhere here, page 4 will be somewhere here, page 5 will be somewhere here. Okay. Now if you want to transmit this entire program to main memory, तो आपको क्या करना पड़ेगा? Every time you have to search this entire secondary memory. So what I will do, so I will have virtual memory in between main memory and secondary memory. और हम क्या करेंगे अभी? Virtual memory का ब्लॉक में डिवाइड कर दिया. अब जितने भी ब्लॉक्स है, जितने P1 के जितने भी इंस्ट्रक्शन, सपोज 1000 इंस्ट्रक्शन, नाउ आई एम गोइंग टू स्टोर दिस 1000 इंस्ट्रक्शन इन सीक्वेंशियल मैनर. ओके, इन सीक्वेंशियल मैनर. अब हम लोग क्या कर रहे हैं, वर्चुअल मेमोरी में जितने भी इंस्ट्रक्शन थे P1 के, हम लोग अभी उसको उठा के वर्चुअल मेमोरी में, लॉजिकल मेमोरी में सीक्वेंशियली स्टोर कर रहे हैं. नाउ व्हाट विल हैपन, नाउ व्हेनेवर, नाउ इफ यू वांट टू एक्सेस दिस प्रोग्राम, ओके, नाउ व्हाट विल हैपन, द एक्सेसिंग स्पीड will be generally more faster than the accessing speed of secondary memory. What is the reason here? Now we are not going to search for the entire hard disk when we are moving this instruction. Now what we are doing? We are simply, we know that where actually it is stored. So the main reason of virtual memory is, one of the main application is to reduce the access time, okay, or to reduce or decrease the access time that is required to transmit a page or a frame from a secondary memory to the main memory. Okay? So simply we can say it is nothing but separation of user logical memory from the physical memory. That means we have an additional memory, okay, additional memory, which is your virtual memory. It is placed in between your secondary memory and your main memory. Second thing, what is the next benefit here? Now we know that, okay, we know that. So suppose this is my main memory. Now this is I'm talking about second application. Why we are using the virtual memory? Okay, this is second application. Now we know that this is my secondary memory. Fine. So हम लोग को पता है, suppose एक program P1 execute हो रहा है. Now suppose the program P1 is executing. So I know that if the program is consist of 1000 instruction, the program is consist of 1000 instruction, so what will happen at any instant of time, I does not require all this instruction. कभी भी आपको ये 1000 instruction एक साथ जरूरत नहीं पड़ता है. तो हम क्या करेंगे, हम उसी इंस्ट्रक्शन को मेन मेमोरी में स्टोर करेंगे जो करंटली यूज होगा. Now suppose out of 1000 instruction, there is only 50 instruction which is currently required. So what I will do, I will only going to store this 50 instruction. Okay. Now rest of the instruction that will be going to store in your virtual memory. और P1 क्या आएगा? P1 आपका virtual memory है जहाँ पर आपका 1000 instruction store है. लेकिन हम 1000 instruction को डायरेक्टली यहाँ पे ऑक्यूपाई नहीं करेंगे. हम लोग कितना करेंगे? 50 instruction. What is reason behind that? Reason क्या है? मेन मेमोरी का जो मेमोरी है बहुत छोटा है. And to achieve the मल्टी प्रोग्रामिंग कॉन्सेप्ट को अचीव करने के लिए आपको क्या करना पड़ता है? Now I have to store number of process in my main memory. Yes or no? है कि नहीं? If you already know the multi-programming concept, multi-programming क्या बोलता है? In any state of time, your main memory should consist of number of program. है कि नहीं? Number of program आपका रहना चाहिए main memory. P4. Now what we will do? Now if of this P1, P2, P4 is 100 instruction, then what will happen? I may not have enough program in my main memory. So what I will do, I will store only those instructions for a program that are currently needed. Rest will be stored in your virtual memory. This is the second application. First application kya tha? It will be increase the efficiency of data transmission between secondary memory and first primary memory. What is second application? To achieve the multi-programming. Okay, what the multi-programming say? To achieve the multi-programming means to maximize the CPU utilization. That means every CPU should not be idle. For that, what we require? We require number of programs in my main memory. And how it is possible? If every program is of 100 instruction, so I may not store if अगर हम लोग सभी प्रोग्राम का इंस्ट्रक्शन स्टोर करने लगे तो देयर मे बी a case I may not store as many as program that will be required by CPU. So what we will do? So we will store the entire instruction in a virtual memory. Okay, for P2 also 1000, for P3 also 1000. Okay, okay, but I will copy only those instructions that are required at particular interval of time. So what will the benefit? The benefit is I can access, okay, I can store as many as program in my memory. Okay, what are third applications? What is the need of virtual memory? Now suppose assume that now my main memory is, I hope it is both the application is clear to all of you. Is it clear? Both the application? Why we require a virtual memory? Yes or no? Is it clear? No one is responding. Is I audible? Is I audible?
Yes, sir.
Is this both application is clear till now? What is the first application? We have virtual memory की यूज करते हैं. पहला बात जो है जो भी डेटा एक्सेस टाइम है in between main memory and secondary memory can be reduced. Third second application की यूज करते हैं. Now to increase the number of program in my main memory, I will use the concept of virtual memory. So what I will do? So I will not going to store the entire instruction. Suppose there is 1000 instruction, so I will not going to store 1000 instruction in my main memory. I will only store those instruction which is currently needed, and the rest of the instruction will be stored in a virtual memory. So what is the benefit here? Now the benefit is it will improve the number of programs stored in virtual memory, which will improve your multi-program. Third one, now assume that suppose my main memory is of 500 MB. Okay. Now suppose the main memory size is of 1 GB per minute. Okay. Now suppose the main memory कितना है 1 GB. Now suppose we want to run a program. We want to run a program that is of size 2 GB. Fine. So how it is possible now? For example, अगर real time example देखते हैं, अगर suppose nowadays what movies, okay, high definition movies, if you see, that will be around 2 GB to 4 GB. Yes or no? अगर high definition movies आप देखते हो, तो आपका कितना होता है 2 GB to 4 GB. Or any program, larger program like MATLAB program. Okay, if you run that MATLAB program, you can see the program is somewhere around 8 GB. ठीक है, MATLAB program run करते हो और बड़े programs, it will be something like 8 GB. So how it is possible now for running this program? I have to copy. What is the concept? What is the basic concept क्या आपका? अगर मेरा ये 2 GB का है, तो ये प्रोग्राम अगर 2 GB का है, तो मुझे ये पहले कॉपी करना पड़ेगा 2 GB का. Now it is possible. Is it possible? No, it is not possible. What is the memory available? It is 1 GB. The memory available is 1 GB. So how can I store this 2 GB? So what I will do now, here virtual memory play an important part. Now what I will do? So I will have a virtual memory. Okay. of size 2 GB. So I will copy this 2 GB here. I will copy this 2 GB here. Now I will transmit only those data out of this 2 GB. Okay, 2 GB program. हम उसी डेटा को ट्रांसमिट करेंगे जो currently required है. Okay, that is currently required because the program, suppose the example of movie. So if you play the movie, okay, the movie will be played frame by frame. Okay, frame by frame. So what will happen? So in this 2 GB program, what frame is required, that frame is transmitted. So this is another example of virtual memory. So whenever the program size is much larger, okay. So whenever the program size is much larger than the main memory, so we will use a concept of virtual memory, and only those frames are transmitted to the main memory that are currently needed. Fine. So this is the basic concept of virtual memory. First of all, you have to understand the virtual memory is nothing but a logical memory which is placed in between your physical memory, that is main memory, and the secondary memory. Okay, the first part. So there is no real existence. There is no hardware in my architecture like virtual memory. It is only a logical concept which is used for basically three main applications. First application is it will use to efficient data transmission between secondary memory to the primary memory. Second thing is it will increase the number of multi-programming in a main memory so that the CPU utilization can be maximized. And the third point, if the program size is much larger than main memory, now we cannot store the entire program in my main memory. So what we will do, we will use the concept of virtual memory, and only those frames are transmitted that are currently used. Okay. Now whatever we discuss, that things are written here in the part. So you can see here the first point is only the part of the program needed to be in memory education. So we does not require to entire program to store. So we will store the entire program in our virtual memory, and only those part of the program is transmitted that is currently used. Second thing is the logical address space can therefore is much larger than the physical address space. So I can improve, okay, I can extend the my physical memory concept. Now it will allow the address space to have a say in several processes. Now I can increase the multi-programming concepts also. And finally, it will allow a more efficient process creation. Now, number of process creation, we know that once the process is in active state, we can say the process is created. Fine. So that will be improve your process creation. Okay, so if you want, you can write this point. Just note down this point. And how this virtual memory concept can be implemented. How it can be implemented? So it can be implemented by two logic. One is your demand paging, and second one is your demand segmentation. By these two methods, we can implement the concept of virtual memory. Okay, note down if you want to note down something from this slide. Okay, so let's move on to next slide. Yes. So this particular figure, okay, this particular block diagram, so how it is implemented, how we are implemented. Now, this is my main memory. Okay, this is our main memory that we are having for the physical memory, and this is our secondary memory. Fine. And there is a virtual memory in between these two. There is a virtual memory. You can see this is my virtual memory. And the very important thing, how we can map. That means, so whenever, now what will happen? So whenever there is a request of any frame, okay, there whenever there is request from any frame, now that will be mapped from the virtual memory to the main memory. Now that we are using here a memory mapping technique. Like in case of paging में जैसे हम लोग ने पढ़ा था memory mapping technique. Here also we will use a memory mapping technique. Okay, memory mapping technique that can be used to transmit the pages from virtual memory to the main memory. So we will discuss this one, this memory mapping technique, how this memory mapping technique can be performed. Now this particular diagram so that how the virtual memory, okay, or the implementation of, or we can say how this virtual memory is larger than physical memory. So it will be act as in your physical memory where the size is much larger. So as we have already discussed, the concept of virtual memory can be implemented by the two methods. One is your demand paging and second one is your demand segmentation. So let us discuss the very first method, which is your demand paging. So what does demand paging say? So we will bring the pages into the memory only when it is needed. Okay. So what we will do? So the pages that is now there is a pages in a virtual memory. Okay. Now there is a number of pages in my virtual memory. Suppose this is my page 1. There is a page 2, page 3, page 4. Okay, like this it will continue. So what we will do? So we will not, now suppose this is my main memory here. Now I'm having a main memory. So we will not bring these pages in the main, as we know that the size of the main memory is very limited. Okay, the size of the main memory is very limited, and we have to utilize this main memory size of the main memory very efficiently. So we will not going to place all the pages. We will not going to place all the pages that is in a program. Suppose any program P is having a pages. Suppose page P1 to page P50. So what we will do? So we will not going to place. Now we will not going to place all these pages from P1 to P50 in my main memory. Okay. So what will happen if you place this all the pages? Now it will occupy more space, and the concept of multi-programming cannot be achieved. So what we can do here, instead of placing all the pages, so we will store all these pages in my virtual memory. Okay. This is my logical memory. This will be going to store in a virtual memory. And I will transmit only, I will bring back only those pages into the memory which it needed. So whenever the program is needing this page, so I will transmit. So whenever this required a page P1, so I will transmit to the main memory. So whenever it required page P2, so I will transmit to the page P2. So on demand, I'm transmitting. So this is a reason it is called demand paging. So whenever there is demand of this particular page, so whenever जब कभी भी उस पेज का डिमांड होगा, तब हम लोग उसको वर्चुअल मेमोरी से मेन मेमोरी में ट्रांसफर करेंगे. Only reason जो मेन रीजन यहाँ पर है आपका वर्चुअल मेमोरी का यूज करने के लिए, एक तो आपका है एफिशिएंसी को इंक्रीज करना है, जो एक्चुअली का मल्टी प्रोग्रामिंग, और वो ऐसे कैसे अचीव होगा? You have to increase the size. So physically we cannot increase, so that's why we created a logical memory here. It is called the virtual memory. So what is the benefit of demand paging here? The benefit of demand paging, you can see here, the first benefit is it requires less input output need. Okay, so demand paging का जो best benefit है वो आपका कहना less input output need होगा. Second thing is your less memory is needed. So as we are not transmitting the entire pages to the main memory, so we are transmitting the pages based on the demand. Okay, so that is the reason it will require less memory is needed. Fourth advantage is faster response. Okay, as we are not directly communicating, now we transmit these pages from transmitted pages to main memory. We are not directly communicating. With the secondary memory, we are communicating with the virtual memory. So what is happening here? The response, the fastest response time of accessing speed is very much faster. And the final advantage is more users. That means more program can be stored. Okay, the more program can be stored in my main memory. Okay, now how we can find the particular page which is required. Now that we will have a page needed. Okay, there is a concept of page needed which will be referred to. So whenever the page is needed, we refer to it. Now there will be two things. One, basically we are having a bit operator there, or page bit operator, which will be decide whether the page is valid bit or invalid bit. If it is an invalid reference, if the page that are needed or it has demanded, if it is invalid, so we will abroad the program. That means we can understand the page that is requested is out of this program. Suppose the program P consists of page number 1 to page number 50. Now suppose the CPU is requesting for the page number 100. Now this is an invalid bit or invalid reference. So as we know that the page 100 is not belonging to the particular program. So what I have to do? So I have to make sure that the request is invalid. So I have to make that bit, the page bit to invalid, so that the program can be encrypted. The second reference is if the requested page is not in my memory, then what I have to do? Now I have to bring back the pages to the memory. The simple thing, how this demand paging concept is working. Very simple. सबसे पहले जो पेज आपको रिक्वेस्टिंग है, suppose the page I have required the page, suppose I requested for the page 15. Okay, now I will find in my main memory आप search करोगे page 15 नहीं मिलेगा. Now if page 15 नहीं है, then I will request on demand basis. Now give me the page number 15. So whenever this reference is associated, now there will be two things. Now with the page number, so I will have additional column here, which will be going to store your valid and invalid bit. Now this is a valid bit. If it is a valid bit, now this page 15. Now suppose this is my page 15. Now this is a valid bit. The request which is made, it is a valid one. So now what I have to do? Now I have to bring back that page 15 to the main memory. Now suppose assume that it is requesting for page number 100. Now what will happen? Now you're never going to find the page number 100. Okay, because that request is invalid. That means I have to store invalid bit. Okay, IV stands for invalid. That means whatever requesting you are making, it is whatever the page request that we are making, that is not present in your virtual memory, or that is not present in scope of your program. So this is an invalid request. So what we have to ensure that if it is an invalid request, the program should be terminated or it should be absorbed. So this is a basic concept of demand paging, how the demand paging is implemented. Demand paging is the page on demand should be bring back to the main memory from the virtual memory. So yeah. So this is an example of this particular block diagram. So the example of uh, the page memory of continuous disk space. Okay, how secondary memory, how swap in and swap out is performed if the program, okay, if the program are stored in continuous disk space or continuous fashion. Okay, if the programs are stored in continuous fashion. Now this is my program A. You can see this program A is stored continuously. Okay, now this is my program A is stored continuously, and this is my program B, which is stored continuously. Okay, so suppose if the program is this finishes execution, so now suppose program A is finished execution. So what I have to do now, I have to perform a swap out. That means I have to remove this program from the main memory, and I will go to store in my secondary memory. Okay, and whenever there is a request, okay, so I will bring back this program. Suppose now program B, here the program B is requested and it is not present in my main memory. So what we will do, so we have to swap in. Okay, we have to swap in this particular program B from the secondary memory, or you can say this is before this is my virtual memory. If I say this virtual memory, okay, now this is swap out and stored in my virtual memory, and the program that is on demand, the program that is on demand, it is swapped in to the main memory. So what is happening here? Instead of directly communicating with the secondary memory, we are communicating with the virtual memory. So which is improving the efficiency. So this particular diagram shows how we are performing swap in and swap out based on this continuous memory location. Okay, the next is how valid and invalidity are used. So I hope the time is going to end in 2 minutes. So I will not start this topic. So as we're not going to cover. So let me again just revise what we have discussed today. So we have discussed the basic concept of virtual memory. Then we have seen what are the applications or why we need a concept of virtual memory. Then we have seen how we can implement. There are two methods. One is demand paging. Second one is demand segmentation. So we have discussed a simple how demand paging technique can be implemented. Okay, and what are the rule of valid and invalid bit during the implementation of demand paging. So with that, we will stop. Okay. So those who are not given attendance, they can scan this attendance. Okay. Those who are not given, just scan this attendance. And we'll continue in next class. Okay. Rest of the topic will continue in the next class.